Okay, let's have a quick read of this question. The masses in grams of plums in a certain kind of distribution is that. Find the probability that the plum chosen at random has a mass between 50 grams and 60 grams. Now all you need to do is put this information in your calculator, go into distribution mode 7, and what you do is once you put in all these, now don't forget that the mean is 55, and now this one is the variance, so don't forget you need to put in standard deviation, which will be root of 18. Okay, make sure you do that, and then you just put it in through your probability, this being your lower bound, okay, and this being your upper bound. And if I quickly do that, you should have got putting those in, should have got a probability of, now it's written like this, if we call that x, these plums x, it's between 50 and less than 60, and that probability will give you 0.761. Now you only need to give it to 3 single figures, so that's fine, and there's only one mark in it, so that'll be enough. Now it goes here, the heaviest 5% of plums are classified as extra large. Find the minimum mass of the extra large. Now this 5%, now I'm just going to draw quickly here the distribution table. Normal distribution goes like this. Now the medium here, or the mean, this is what the weight is, 55. Okay, so the area underneath this graph must equal 1. Okay, and what we've been told that calling this E for extra large, this extra large, everything greater than that will be 5%, which is 0.05. Now again, you go into your calculator. This time you're using inverse because you've been given the area. Okay, the area is going to be 0.05. Now just be careful, because I did it first in the calculator and I put it as 0.05, and I got a value which was less than 55. That's not a problem, because what your calculator does sometimes, it takes the area here as being 5%. Okay, so all you need to do is, if that gives you a lower value, you've taken the lower bound, so that would have been an extra small value. Okay, don't worry about that. You just need to go back and do 1 minus 0.05 in your calculator, which gives you the area of 0.95. Now if you plug that as your area with these mean being your 55 and standard deviation being the root of that, okay, you should get E to be to 3 single figures. I got 62.0 grams. Now don't write, just write 62.0 to 3 single figures just in case. Okay, so that's what you would expect the lowest one to be. Now it does say minimum, because you would get sometimes higher than that, but anything 62 or higher would give you that probability of being selected. So that's why they chose that word, minimum. Now it goes here, the plums are packed in bags, okay, each containing 10 randomly selected plums. And it goes here, find the probability that in a bag chosen at random, the total mass is less than that. Now there's a couple of ways of doing this. I think the best way to do this is, because this is our random sample, we can use it as a sampling rather than the total. But there are 2 ways of doing this. I'll show you both. Well, we'll see how it goes, and then if you like it, if you want to see the other way, I'll show you that. Okay, so what you could do here is, I'm going to go number 3, put a star here, so we do it here. And what you can say that n is, the random sample is 10. So these apples, my sample apples, have a distribution. Now what I'm going to do is, I'm going to take the average of that. Okay, so first of all, before I do the average of that, x choose this distribution. We're saying that it follows the same distribution as this normal distribution, which is 55. However, our variance is going to be shared by our sample that we took when we're going to divide it by 10, and don't forget to square root all that. Okay, square root everything. So whatever you put there, put it underneath there and square root everything, and your calculator will do that automatically. Now once you've done that, you then say we want to know that our sample, what we selected, is less than that. So we're going to say that, so the total added up to 530 grams divided by 10, which was in there. So we want to know what is the probability of our sample mean that we got in here. It's going to be less than 53 grams. That's what we need to work out. Okay, so we're taking it as one individual value by dividing by the hour sample. We want to know what that is. We're going backwards, so we're going through there. Now, just out of curiosity, just because this variance, because this one is for 1, when we're taking 10, you make it, because it's a much smaller, rather than the whole population, we're only doing it with this sample. That's why we divide it by that 10, okay? Because it's a much smaller population. It's a smaller sample. Now, once we've done that, if you get your calculators, put it in, just put those conditions in, go into mode 7, and you need to work out what is the value of this sample mean being less than 53. And if you put that in your calculator, you should get the value 0.0680. That's the chances of that happening. Just double check it, make sure you all got it. If you haven't, I'll come around. You got that? Okay. Now, there is another way. If you don't like this way of doing it, I'll show you an alternative way. 6 and 2 threes, they both will work. The other thing is, you could have taken it as the total weight. Okay. The only thing with the total weight, now everything's being multiplied by 10 times. Okay. So you could do the same thing, and if you wanted the total weight, so this is individual, what you had is 10. You could have said that X follows a distribution, but this time you got 10 lots of that, so that makes it 550. I'm going to put all here. You could use this method, and you got 10 times as much as that distribution of the individual one, so that becomes 180, that variance. Again, using that, and then you could say what is the probability that I'm going to, rather than X, sorry, can I call that the total weight? What is the total weight, chance of the total weight being less than 530 grams? Again, if you put that now with these conditions in your calculator, you should get the same probability. Just check that. So that's another way of doing it. That's just the total weight. Okay. Are we okay with that one? Don't forget to square root that. 180 has to be square rooted, because that's the variance. Okay. Yeah. Always, that's the variance. When you put it in the calculator, this is always given as normal distribution mu, and this is variance. So you must root it. Always given like that, unless it states otherwise.
When it's in sample, do you root the whole thing to not put it in?
You root the whole thing.
Yeah.
Sometimes you see this written like this, where they already rooted that and then they root that for you.
Yeah.
But where that comes from is the variance over n, all rooted. They rooted the top because it was a square, and then they left that as root n. Okay, that's where it just comes from. Right. Okay, let's have a look at part B. I'm going to just quickly put all this in a box, shrink it. Oh, not there. I've got some more space. Just keep that one side. Okay, so let's have a look at part B. Actually, one with them, just going to clear it. Let's just get rid of that. Let's do part B now. Okay. B. There goes. The masses in grams of apples of a certain kind have this distribution. Okay, so they're different, so I'm just going to call this Y as the distribution of, this time it's told you that this is the mean and this is the variance. It is given that half the apples of the masses are between these weights. Now what it's saying there is, again, always sketch a graph. And it's telling you that Now 67 is in the middle, so this is giving you a clue that 67, and then it's telling you that 62 is here and 72 is here. Again, what they've done, if you look at it, they've done plus and minus 5 on each side. So the plus 5 there and the minus 5 there, minus 5 grams. And that's their way of saying to you, this is exactly bang in the middle. And that's half, so that's going to be 0.5. Okay, so listen to the clues what they're giving you. So they're telling you that is symmetrical at that point. So if you took 1 away from that, that will give you 0.25 and 0.25 here. Again, we have seen a similar question to this in the previous paper. So it's just giving you those hints, making sure. Now it doesn't really matter which side you take. Okay, I'll do both of them to make a point, but you've got to get the same value. It goes there, determine the value of the standard deviation. Now, it hasn't given you information here at the moment how to do this. So what you need to know is, well, what you need to do, what your calculator will do, is standardize this. Okay, so you need to standardize this distribution. Now the way to standardize the distribution is you get your x value, you would have seen this before, or this case it's going to be the y value, you minus the mean and you share it by standard deviation. This is standardization. Okay, and this follows, this is equal to z value. This would then, you can use the z values. Okay, so you've standardized this. Now the importance about this, the z standardized value follows a normal distribution, where obviously when you take the mean away from the mean, that becomes mean 0. And because you divide it by the variance divided by variance, and that will give me a variance of 1. Okay, that's the beauty about that. You can now standardize it and just put that in your calculator as a standardization. So what do? We do 67. So we know that that is 67. We're going to standardize it, so we're going to take away the mean. Okay, sorry, can I just say this again? Let me just clear that. So what we got here, we're going to standardize it. So we're going to get the value what we got between these two. So it doesn't matter which way round we go. We're going to go for the upper band or the lower band. They both will work. I'm just going to use this value at the moment. Let's say 72. So if we said probability that y is greater than 72 grams, now the chances of that happening is going to be 0.25, because we know from here it's symmetrical. Okay, or you could have said probability of this y distribution, because this is the distribution of y, y is less than 62 is also equal to 0.25. Okay, that's the chances of using it. Now just be careful, like I said to you, I think your calculator, when you say it's greater than, you need to take 1 away from there. When it's less than, you just keep that probability. So we'll do both of them just to prove a point. Now first of all, we standardize it. Are we okay with this point so far? So standardize it, we take, we're going to call that z eventually. Probability z is going to be greater than, how does z come about? We'll get the 72, we take away its mean, which is 67, and then we share that by the variance, which is square root of, share that by a standard deviation, which is square root of sigma. Okay, and that's going to give me a probability of 0.25. Now in your calculator, can you use this standardize? What I want you to do is go and get your calculator, put 0 as mean, 1 as your variance. Okay, if you want to square root it 1, you'll still get 1. And this time, can you do 1 minus, can you put in 0.75? Can you just tell me what do you get there? Because I'll quickly do this. 72 take away that is 5 over variance, and that will give me, now don't forget we're using inverse probability here, sorry. So you hope you're using the inverse probability with the area of 0.75. Rob, you need to do the same, not just rely on her coming out. Have you done it? Can you tell me what area you got, please?
0.674.
Yes, 0.674. Brilliant. Now, that's what that's giving you. So if I want the mean here, I just need to rearrange, divide that, rearrange it, and Claire, what did you get, please, for this one? You just switch those around.
7.41.
Excellent. 7.41. So that is going to be our standard deviation. Now you don't need to do this again. I said with or, but I'm going to take you through this just to convince you that it works both ways, but don't do both ways in the exam. Can you do the same thing here, please? But this time, this value would be 62 minus 67. So that's the z value, what you got to get here, divided by sigma. Is going to equal, and this time in your calculator, can you put in the probability? Now again, can you put standardization, put your mean as 0, put your variance as √1, standard deviation as √1, and can you this time put the probability as it is, 0.25? You should get what Robin said earlier is a negative 0.674. Okay with that? And this would have been negative 2. 62 take away 67 is minus 5 over sigma. And this time you do get the same value, but it's the same calculation here. Two negatives will cancel, and hence you determine that sigma is 7.41.